and welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Kevin Buckner.
Thank you, William, and welcome to our KYZEN Tech to Tech presentation. Today, we're going on to the remanufacturing again, and this one is the final clean, right? So we're going to talk about parts, engine blocks that have been machined, they've been cleaned, they've gone through the whole process, and now they're going to that final clean. They're going to that clean before they go into paint and assembly, right? So the problem. A large remanufacturing company, they need to remove all the machine oils, okay? So you get machine oils and you get chips, and I love the swarf is the typical name for it, from steel engine blocks. And this is all before they go into paint and assembly. So they purchased a new inline washer, and it's a big washer, we'll see it in a minute, to replace all of the outdated equipment that they have on their floor and combine it into one process. So because we work with these guys on their 6353, 6355 chemicals for the carbonaceous and the nasty oils removal, they selected us to provide them with a solution to clean and also give some type of rust protection. We call that CP, corrosion protection, before it goes into final assembly, if you will. So the process that they have, this is a picture of the cleaner. This is actually just part of the cleaner, if you will. It's a new inline washer. It has one wash section. It has two rinse sections, and it has one dry section. This is just that front side. So this is just the wash and then the two rinses. So we installed one of our combination products, and that's our METALNOX 6314 CP. The CP is corrosion protection. So it's a combination. It has a cleaner and it has a little bit of corrosion protection. The reason we do that is because the time in between the wash and the rinse, you have an opportunity, because of temperature and belt speed, you have an opportunity to flash rust. So we want to give it a little bit of protection before it goes into that rinse water and starts actually rusting on the steel. We also look at what goes on during the rinse. So we decided to add a small amount of our CP90N into the rinse section at 1%. And the reason we do that is once it goes through that engine block may sit for a little while before it actually gets painted or before it goes into its next process. So continuing on with the process, we took a look at these engine blocks as they come out of their machining process, and we saw that not only they're coated with the coolants and everything else, stuck into that coolant and inside water jackets and inside sleeves, you see these chips, right? You see the swarf all just laying in there. We made a recommendation to them that they do a quick hand wash just to try and flush some of that material set out before it goes into their wash. They're already going to get enough chips and swarf coming out when this machine blasts these parts with this cleaning chemistry to get all of that out of there. So we advise them, put this in your process first. Let's get rid of the big stuff first, and then we can address the remainder of the material set through filtration. This is called super filtration. So all of the chips and all of the swarf that's left on that engine and then has to come off, we release it, right? So when we wash it with the alkalines, we're breaking down everything and releasing all of those chips. If you don't have super filtration on some type of equipment like this, these chips and that swarf, that goes down inside to your pumps. You're not going to hold a pump very long if you don't filter that material set out. This is 4 36-inch stainless steel filter housings per wash. So you see there's 3 sections. There's 4 of those on each section. And those get changed out quite frequently because the amount of swarf and chips that are still coming out of the engines. During the process, of course, we're process inspection. So we fill the equipment, we start running the equipment, we bring it up to temperature, and then, oops, not all goes as planned, right? So we notice through this section that we actually have water coming out of the lid. That's the lid, the viewing lid. You take that lid off so you can see inside your equipment. The water level has risen gone over the top float, the shutoff valve, and continues to rise. So we see this chemistry water start coming out through the top of the lid, shut the machine down, and come to find out it's actually swarf has gotten in the top level switch. It's just a finger switch. It's gotten inside there and it's jammed that switch on the low side, so it's continuing to fill. So we have to get in there, take that lid off, find those switches, they're never in the most convenient places, and clean that switch and get that thing up and running again before we even start running the trials. So this is an engine block. Typically, as it enters the wash section, you'll see it's just on an inline belt style cleaner. We did decide to pick a generic starting point, right? So we of course know the chemistry, the 6314 CP. We're going to start at 13% concentration. We're going to run at 145 degrees F, and we're going to run a belt speed of 2 feet per minute. That's a starting point. From there, we can actually start to dial in a process, if you will. And if you know me, we always talk about concentrations. We can dial in concentrations. We can make other adjustments as we see fit to give you a correct process as we run through. So we ran this block through, and after a single pass, we've got some rust. And you can see this is a very, very small amount of flash rusting that hadn't been seen previously. So we know that through the process that we have in place, something's not quite functioning correctly and allowing this small amount of corrosion to show up. So we took the second block as it came through and we did a pre-inspection on it. Now, the pre-inspection showed that this was already on the block. There was already some type of discoloration. The spots were there. They were barely visible, but they were there. But as soon as it went into the wash process, it just enhanced and made those spots way more noticeable. Is it a problem? No. It's a solution, right? So we give solutions. So what we did, we said, okay, what can we change and get a good process going through cleaning these engine blocks? So what we did, we reduced the heat in the wash and the rinse sections, and then we slowed the belt speed down. And this is to help the CP in the 6314 CP improve its saturation, improve its effectiveness, if you will, as it goes onto the part itself and helps mitigate that type of a problem. So in talking with them, we noticed that the machined engine blocks, as they're coming over from their CNC, that's where we're starting to see this corrosion. So we came up with a plan to say, let's put some of this CP90N into the coolants of the CNC machines. Now we can mitigate or prevent, if you will, that little rusting spots from appearing before they get over to our rinse. So we're stopping the problem before it gets into this actual wash process. So we just want to make sure that they're rust-free before we see them, before they come over to us. When I talk about concentration, when I talk about control of concentration, you know I love this system. This is the Conductivity Control System. This works on conductivity inside the wash tank itself. We'll take a reading of that conductivity. We send that over to a controller. The controller then will send a signal over to a pump. That pump, you can increase the stroke frequency, how fast it goes, or the stroke length, or both. So we actually can speed that pump up and make a longer pump stroke to add more chemistry, to bring the level of chemistry up higher quickly. When we start to reach that point of specification, 13% in this case, it starts to slow down the frequency and it starts to shorten the pump stroke. So we're not adding as much chemistry into the mix, and we can slow that down and then get the correct concentration as we get closer to our actual set point. You ask, is something like this right for you? Well, it reduces costs and it promotes safety. I don't want guys having to, carry 5-gallon pails of material set and pour them in with the possibility of splashing, and, 55-gallon drums with rollers and trying to add chemistry into the machine. This does all of that for you. So the safety aspect on this is really, really big. We talk about requiring a little floor space. Floor space is so valuable in all these factories. Well, they already have a 55-gallon drum. The nice thing about the CCS, it sits right up on top of the drum. It's on its own stand. So it's taking vertical space, not horizontal space. That's all still contained. We talk about very low energy consumption costs. It's a 110 device. It simply plugs into an outlet. That's all it does. So no pre-wiring has to be done, and you don't have to change a factory. It's very, very easy to get up and running. It ensures the correct amount of chemistry because that stroke frequency and the stroke length, we can control and stop those peaks and valleys of high concentration, low concentration with a device like this. And it's fully automatic. Once we set it up, it's going to go and it's going to do what it needs to do without a lot of babysitting. So I always say, ask yourself these important questions. Do I need to constantly monitor my wash bath for concentration? Those who know me say, Kevin, what range do I need, right? Pick a range. If you know you clean at 13%, go 13 plus or minus 1. So it's between 12 and 14. We're going to clean within that range. This is going to help you accomplish that. Am I concerned about worker safety? Yes, everybody is concerned about worker safety. If I can get you not to touch my chemical or come in contact with my chemicals, I'm going to promote that because that's very, very important. Am I limited on my floor space? Most people are vertically integrated into the system. Could it free up workload for your employees? Yeah, absolutely. When you go into these large facilities, you have to realize that some of these facilities have 150 washers. And if you have to run titration or conductivity or split control method or whatever method you have to incorporate, 150 washers with one guy is a full-time and then some kind of job. This frees them up to go do something else that's more important. And then, of course, you're looking for automation. Are you looking to take out the human aspect of whether we can balance that concentration? If you are, look for the conductivity control system. So in conclusion to our process, the final process parameters we settled on was 13% of the M6314 CP. We ran it at 140 degrees. So we only took out 5 degrees, but 5 degrees can make a big difference in the process itself. We went down to 1 foot per minute on the belt speed from 2 feet per minute. Again, allow the CP to get on and do its job, prevent that rust. And then, of course, we added 1% of the CP90N into the rinse section, running at 120 degrees Fahrenheit. Now, the reason we chose the CP90N to go along with the 6314 CP is in the rinse section, I need to be able to measure how much CP I actually have. So if we go with the nitrate version of the corrosion protection, I can do titration on that, and I can tell you you're at 1%, 2%, 3%. Don't forget, the more CP you add, you're taking a steel, bare steel, and putting a protectant over it to stop oxidation from getting to it. The more you build that up, the more you're liable to see it. So we want to keep that down at that 1% range so you can't even see it. You don't know it's there, but it's protecting your parts. And then, of course, we added that 1% of the CP90N to the CNC coolant bath. And now we've gone over 3 weeks with no rust coming over to our final cleaning process. So frequently asked questions on this topic: why would you add a corrosion protectant product when you already have one in the combination product? Well, we have to give protection not only through our process, we have to give protection as it goes on to the next process. So the 6314 CP gives us great protection while we're actually running in the machine. But we have to add that CP90N to that final process to make sure when that block goes off for painting and final assembly, it may sit for 3 days. So we want to make sure that we protect that product, the engine, the steel engine in Texas, of course, with the moisture that we have in the air. We want to make sure that that product doesn't rust in that short period of time. Can you mitigate the light corrosion spots prior to the final wash? You can. And this takes a little out of the box thinking, but this is where we went over to the CNC machines with the water coolant in there. And that's where we noticed the problem was. We can use the CP90N in that process. We can measure it, of course, nitrate bound. So we can put 1% in there and eliminate any of that problem before it comes over to the final wash sections. What made you choose the 6314 CP as the wash chemistry? Well, it's an alkaline aqueous based chemistry. I don't need aggressive. I don't need mild. I need right in the middle. So I went with the 6314, which is one of our middle grade, if you will, type cleaners, but it had that CP in it as well. That's one of what we call combination products, of course. So it had that little bit of protection, and then slowing that belt speed down, allowing that protection to get onto the steel engine blocks themselves before they went into the rinse really, really helped us out. And will the CCS add water and chemistry? No, it's only going to add chemistry, right? So the conductivity controller, the probe itself, sends that number, sends that reading over to the controller itself, and the controller will determine based on the feedback it's getting, do I need to add a lot of chemistry or do I need to add a little bit of chemistry? We're trying to take the peaks and valleys out. So no, it will only add chemistry. Your machine or your inline, your cleaner will do the rest and add the water section itself. With that, I hope this has been informative, and I'll turn it back to William.
Thanks, Kevin. Thank you guys for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in this session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.